All right, here we go. Let's take a quick look back at Unit 10 here. So, rational functions, got some wild-looking graphs. We're going to multiply, divide them, add, subtract them, and solve them. So what I did here is I made a really in-depth corrective assignment. The review is pretty brief. You know, if you got it, you know what you're doing. Boom, just go take the test, you're good to go. These are problems actually pulled off the corrective assignment. So if you want to go ahead and print that, try some extra problems, not going to hurt you. It's definitely a more thorough look if you need more of a refresher here. So I want to start with number 9. The reason I want to start with number 9, this is everything from 10.1 graphing these things. So if I give you a graph, you know, these little dotted lines are the vertical asymptotes. So when I do this, what are the vertical asymptotes? This would be when x equals, can you see it in here? It crosses at 2, and there's another one here at 0. So again, make sure you write these as equations. This is x equals 0 and x equals 2. It's the equation of that vertical line. Horizontal asymptote goes horizontally, and it's a y equals, and it's y equals -2. And then the intercepts are where does it cross? This one actually has none. It doesn't cross the x-axis, so there aren't any. Does it have a y-axis? Oh, I don't know if I picked the best example, but it doesn't. So you're looking for where would it cross. There's an asymptote there, and it just never makes it there. You'd have to give the points. If it did have one, make sure you give them as points, like 0, 3 or something like that. Awesome. So what if I don't have a graph like in number 1 over here in the corner? What do? Well, to find the x-intercepts, it's like saying, okay, what is x when y is 0? That's what I always think of. So I'm trying to find x when y is 0. Again, when it's a fraction, you're just setting the top equal to 0. This is the y value, so you're like setting it equal to 0. Well, the bottom of the fraction doesn't matter, so you set the top equal to 0. If you factor that, what comes out? This looks like x squared minus 25. So I went ahead and factored the top. And then what do you get here? You get x plus 5, x minus 5. So those are my two solutions, 5 and -5. And again, this is what I was talking about. Write them as x-intercepts. It's going to be -5, 0 is one, and +5, 0 as the other. Awesome. Can we do a y-intercept? Sure, it's the same idea, except you're thinking, okay, when x is 0, what is y? I'm looking for that y value. So this is great. Wherever there's an x, you're going to replace it with a 0. So this would be 2, 0 squared minus 50. All over 0 squared plus 13 times 0 plus 40. So what happens here? All your zeros are worthless, like they just are gone. 0 times anything is 0. So you're left with -50 over 40. If you reduce that, that's what? -5/4. And again, write that as a point. It's over 0 and it's down 5/4. Decimal's cool if you want to write it as a decimal. Excellent. So that's how you find x and y intercepts. What about how do you find these asymptotes? Well, the vertical asymptote is what? When the bottom equals 0. So that bottom should factor. It looks like it factors to x plus 2, x plus 8. And remember, you're setting it equal to 0. You can't divide by 0. It's impossible to divide by 0, so that's when it's undefined. That's what causes that little break in your graph. So this looks like when x is -2 or when x is -8, you're going to have that break in the graph for this. So these don't match the graph. These are just, I just made up these functions over here. How about number 5? So number 4, horizontal asymptotes. Remember the rules. You're looking at the powers, or the degree on top and the degree on bottom. If the degree on top is bigger, there isn't one. If the degree on bottom is bigger, then it's 0 because it's making it really small. But if the degrees are the same or the powers are the same, the highest power here, or the degree, is 2 on top, 2 on bottom. So remember, we take the coefficient. So this would be 5 over 1. So just some rules, and that's really y equals 5. So a lot of rules on that one. Maybe you got to refresh the rules. I just kind of gave them to you quickly there. How about in 10.2? We're going to multiply and divide them. So before we did that, we had to simplify them. So remember, the top in this case breaks down to k plus 3, k minus 3. And the bottom, that's the worst looking 3 I've ever drawn. Let's try that again. So we got -3. On bottom, this breaks down. You can undistribute a 4k, so pull out the 4k and you're left with what? K plus 3. And what are these excluded values? Remember, the bottom we just said can't be divided by 0, or it's like, what makes a vertical asymptote? Well, if you put -3 in here, that would give you a 0, and it can't equal, what is this, 0 over here. So it can't equal either of these, -3 or 0, or else you'd be divided by 0. So we factored it. Why we do it? 1, so we can see our excluded values. 2, because they cancel. And what are we left with? In this case, you're left with k minus 3 over 4k. So that's simplifying. The reason we need to do that is it's going to come up in all our operations here. Can I cancel little things in this? Sure. If I'm multiplying, remember, you can multiply across the top, multiply across the bottom. Does anything cancel? Sure. 5 goes into 24 times. Anything else? 3 goes into 18 6 times. I've got an x squared here is going to cancel out two of these, and I've got this y is going to cancel out one of those. So something like this. So really, on top we're looking at, boom, 24. Did I get everything? Make sure I got everything. And then on bottom we're looking at, what is this? This is just going to be y squared x. So I think we've got y squared x on bottom. Awesome, very nice. How about going down to division? So again, a lot of factoring. You know, you got to factor the top. So the top factors to what? K, that looks like 8 and 4. And on bottom of this thing, it looks like 8 and 5, I believe, isn't it? 8 times 5 is 40. 8 plus 5 is 13. So yeah, definitely. And then remember, the division's different. You got to flip it and multiply. So it's just like multiplication, but you got to flip it. So the bottom actually factors into k over k plus 5 if you undistribute the k. And then the top becomes the bottom. So I kind of did it all in one step here. So I flipped it, factored it. Now we got to cancel it. So what cancels here? We got a k plus 8 over k plus 8. We got k plus 5 and a k plus 5. Anything else? That's it. So what do you have left over? You've got k times k plus 4. And again, you were allowed to leave these factored. I know you could multiply them out, but if you wanted to leave this all factored, you could leave it like that. Awesome. Very good. How about number 18, complex fractions? So a couple different methods. You could flip the bottom fraction and multiply, just kind of like you did here. That just means division. So you're flipping the second fraction and multiplying. Or we said, what's the common denominator? So another method was to say, hey, 7 is here and x plus 4. I could do something like this, times both sides by 7 over x plus 4. What was nice about this is you're going to multiply it out. So when I multiply it out, this 7 is going to cancel this 7, and you're going to be left with x times x plus 4. And then on bottom, what cancels? This cancels this, so you're going to be left with 2 sides times 7 is 14. If you want to distribute that out, no worries, x squared plus 4x, but again, you didn't have to. You could leave it all factored. So there were our complex numbers. So that's a nice little shortcut there, because they get a little more challenging than that when you really get in there. Awesome. How about this? What about adding and subtracting? Remember, you need that common denominator. So if I want to add these together, hopefully this factors. Let's take a look at this. Oh, I like it. This should be y minus 2, y minus 1. And then this factors is the difference of squares, y plus 1, y minus 1, something like this. So I have to do, what are they missing? So this is y minus 2, y minus 1. This is y plus 1, y minus 2. So he's missing a y plus 1. So you got to do something like this. Really, whatever you're doing to the bottom, you're doing it to the top. Remember, we're kind of getting that common denominator. He over here is missing a y minus 2. Whatever you do to the bottom, you got to do it to the top. So really, when I multiply this out, I'm going to distribute this out. I'm looking at 3y plus 3 plus 7y minus 14. So all of that is on top. The whole entire bottom is that whole thing we just wrote out. Y plus 1, y minus 2, y minus 1. That's the common denominator. Then from there, all we're doing is adding combined like terms. So 3y and 7y is 10y. Boom, minus 11. And then I'm going to rewrite that whole thing as fast as I can. There it is. That looks pretty awesome. Nice work, Mr. Brust. Moving on, man, we're pounding these sections here. We've got 10.4. So 10.4, we're solving them. So kind of a mixture of everything. You could try to get a common denominator and all that fun stuff, but remember, this is like saying over 1. I look at it and say, okay, this guy's got an x squared. So I'm going to multiply everything by what? I'm going to multiply everybody by x squared. So what's good about that? So when I'm going to distribute this into all of these guys right here, and then hopefully things cancel out. So for the first one, I'm going to have x squared times 1 all over 1, plus I'm going to have x squared times 1 all over x, and then I'm going to have x squared times 72 all over x squared. So if I did this, I'm going to get rid of my fractions. This is a fancy way to get rid of fractions. You know, ones don't, timesing by 1 doesn't really matter. 1 over 1, so that's just plain old x squared. You know, x squared, one of these cancels, right? So there was like xx on top, so I'm left with just plain 1x on bottom. And then in this case, I'm left with the x squareds cancel. I'm left with 72. Fantastic. So what am I going to do to solve this? Now it's just solving it. It's a quadratic, so we got to set equal to 0. So subtract 72 from both sides. That's good to set equal to 0. And hopefully this factors. If not, I got to do quadratic formula or something. But it looks like it's going to factor, yeah? I think this is going to be negative 9 and positive 8. So what happens here? It looks like x is 9. X is -8. I'm good to go, but I got to check it. What are the excluded values? What can I divide by? In this case, the only one is 0. If I put a 0 in here, it'd be divided by 0. Same thing here. So you gotta look for those excluded values. That's my excluded value, but none of them are excluded. If they were, you would just write extraneous solution by it. But I'm coolio. I'm good to go on that. Doesn't really matter. Awesome. That is it. That is the entire chapter in a nutshell. I hope that helps out. Try the review or try the corrective, and good luck. Peace out.